Hi friends, welcome to Appsc AE free online classes. ఈరోజు పేపర్ 2కి సంబంధించి ఫ్లూయిడ్ మెకానిక్స్లో డెఫినిషన్స్ అండ్ ప్రాపర్టీస్ ఆఫ్ ఫ్లూయిడ్స్ అనే టాపిక్ని చూద్దాం. ముందుగా బేసిక్ డెఫినిషన్స్. వాట్ ఈజ్ మీన్ బై ఫ్లూయిడ్ మెకానిక్స్? ఇట్స్ అ బ్రాంచ్ ఆఫ్ సైన్స్ విచ్ డీల్స్ విత్ ది బిహేవియర్ ఆఫ్ ఫ్లూయిడ్స్ at rest as well as in motion. Fluids are nothing but liquids or gases. The study of fluids at rest is called as fluid statics. The study of fluids in motion where pressure forces are not considered is called as fluid kinematics. The study of fluids in motion where pressure forces are also considered is called as fluid dynamics. The next topic is fluid properties. In that, density, it is also called as mass density. Okay, it is defined as it's a ratio of mass of fluid to its volume. It is denoted by the symbol rho. Mathematically, rho is equals to mass of fluid by volume of fluid. Mass is measured in kg, kilogram. Volume is measured in meter cube. The unit will be kg per meter cube. Okay, dimensions. How to write dimensions? Based on the unit only, you write dimensions. Dimensions are write in MLT form. Here M refers to mass, L refers to length, T refers to time. Mass, unit of mass is kg. Length unit will be meter. Time unit is second. Okay. So the dimensions for mass density is written as, it is the unit kg per meter cube. Write in dimensions as m by L cube, that is equals to MLT form m L power minus 3 T power 0. Okay, I hope it is understand how to write dimensions for mass density. The value of density of water is 1 gram per cc or 1000 kg per meter cube. In numericals also, if the density of water is not given, you take 1 gram per cc or 1000 kg per meter cube. The next fluid property is specific weight. It is also called as weight density. It is the ratio of weight of fluid to its volume. It is denoted by the symbol gamma. Gamma is equals to weight by volume, weight of fluid by volume of fluid. There is a relationship between weight density and mass density. Weight density is equals to mass density into acceleration due to gravity. If acceleration due to gravity is not given in the problem, it is 9.81 meters per second square. SI unit for weight density is Newton per meter cube. SI unit is a derived quantity. In India, we have two system of units. One is MKS unit. Second one is CGS unit. M refers to meters, K refers to kilogram, S refers to seconds. Okay, in CGS, C refers to centimeters, G refers to grams, S refers to seconds. Hope it is understand. SI unit Newton per meter cube for the weight density. Newton in SI unit converted into MKS unit in kgf. The dimensions kg m, f has units of meter per second square. So L by T square into 1 by L cube. Okay, it gives m L power minus 2 T power minus 2. Dimensions also clear now. The value of specific weight of water is 9810. 9810. The next fluid property is specific volume. It is defined as the ratio volume of fluids to mass of a fluid. The other way of defining is volume of fluid occupied by a unit mass. Mathematically, specific volume is equals to volume of fluid by mass of fluid, that is equals to 1 by rho. Specific volume is reciprocal to mass density. Mass density reciprocal to mass density. The unit for specific volume is, it is a reciprocal. K rho has units of kg per meter cube. So the units for specific volume is meter cube per kg. Okay, dimensions, how to write dimensions and how to derive dimensions we see for the two quantities, that is mass density and weight density. In the same manner you derive the dimensions for specific volume also. It is commonly applied for gases, not for liquids. Specific gravity. It is defined as the ratio of weight density of a fluid to weight density of a standard fluid, or it is the ratio of density of fluids to weight density of fluid. Okay, it is also called as relative density. It is denoted by the symbol S. What is standard fluid? For liquids, if you calculate a specific gravity for liquids, the standard fluid is water. If you calculate specific gravity for gases, the standard fluid is air. S is equals to, in mathematical way of representation, S is equals to weight density of fluid by weight density of standard fluid. Okay, for example, I have a specific gravity of oil. I have a specific gravity of oil. I need to find mass density of oil. So what is the formula I use? S is equals to rho of oil by rho of standard fluid, that is water, I use. Okay. It has no units because weight density by weight density or mass density by mass density, same quantity is in ratio, so there is no units for specific gravity. Specific gravity of water is 1 and specific gravity of mercury is 13.6. Okay, I hope it is understand. The next property is viscosity. Viscosity. What is meant by viscosity? It is defined as the property of a fluid which offers resistance to the movement. Movement refers to the flow. Flow. That means viscosity is a fluid property which offers resistance to flow. Which offers resistance to flow. of one layer of fluid over another adjacent layer of fluid. Okay. For example, it is a bed of canal. This is the particle of water. This is also a particle of water. It tries to move in this direction. The flow is in this direction. It tries to move in this direction, but some force or some resistance has to stop to move this flow of the bottom molecule of water, a bottom particle of water. This is due to viscosity. If you take the top particle in the flow, it has to move because the viscous force, the resistance to flow has to reduce when it moved to upwards. Okay, I hope it is understand. The formula for this is tau is equals to mu du by dy. Okay, it is based on the Newton's law of viscosity. What it states that? It states that the shear stress is denoted by tau is directly proportional to a rate of shear strain. If you remove the proportionality, you put constant, that is mu du by dy. That proportionality constant is called as coefficient of viscosity. Okay, now it is understand. I hope it is understand. See, what is the terms? Tau is called as shear stress. Du by dy is called as rate of shear strain or rate of shear deformation or velocity gradient. It has three names: rate of shear strain, rate of shear deformation, or velocity gradient. The proportionality constant mu is there. Mu is called as coefficient of dynamic viscosity. This is I hope this is understand. The next topic is units. You see the definition of viscosity. Newton's law of viscosity also is. See the units of viscosity. Now the units of viscosity, that is mu. Tau by du by dy has units of Newton per meter square. It is velocity u, that is meter per second per meter. Meter get cancelled, that is Newton second per meter square is the unit for dynamic viscosity. You know that force has unit of newtons. Okay, pressure is units of Newton per meter square. That is also called as Pascal. Okay, now this Newton second per meter square is written as Newton per meter square is written as Pascal into seconds. Okay, understand? That is the SI unit. This is derived quantity. MKS unit will be, in MKS unit, Newton is written as kgf. In CCS unit, it is in MKS. mks. In CGS unit, Newton is written as dyne, that is gram force. So the MKS unit will be kgf second per meter square. CGS unit will be dyne second per centimeter square. That is, CGS unit for viscosity is poise. Poise is equals to dyne second per centimeter square. Okay, it has dimensions. Newton has dimensions of m, l, t power minus 2. I know how to write dimensions in the previous two quantities, so I directly write the dimensions for the viscosity. N has dimensions of ml t power minus 2. SA has dimensions of t. M square has dimensions of L square. So the dimensions are m l t power minus 2 into t divided by L square, that is equals to m l power minus 1 t power minus 1. It is the dimensions for viscosity. Next one is note. That means you have to remember these points for your problematic or in a direct MCQs also. One poise is equals to 1 by 10 Pascal second. So 1 Pascal second is equals to 10 poise. Okay. The second point is viscosity of water at 20 degrees Celsius is 0.01 poise or 1 centipoise. Next topic is kinematic viscosity. Kinematic viscosity is defined as ratio between dynamic viscosity and density of water. Density of fluid. Dynamic viscosity by density of fluid is called as kinematic viscosity. It is denoted by the symbol nu. Mathematically, nu is equals to viscosity, that is dynamic viscosity by density of fluid. So nu is equals to mu by density, that is rho. The SI unit will be meter square per second. How it comes? Nu is equals to mu. Newton, that is I write it as in SI unit kg force second per meter square divided by the kg per meter cube. Kg get cancelled, meter square get cancelled. F has units of meters per second square. So 1 second get cancelled, that is meter square per second. This m goes here, that is meter square per second. I hope this understand. This is the SI unit or MKS unit. The CGS unit will be centimeter square per second, that is Stoke. 1 Stoke is equal to 10 to the power of minus 4 meter square per second. Dimensions: meters has dimensions L square, per second t power minus 1. minus 1. Okay. Next topic is variation of viscosity with temperature. Temperature affects the viscosity. Okay. Viscous forces in fluid are due to cohesive forces and molecular moment transfer. Okay. What is meant by cohesive force? Cohesive force refers to the force of attraction between the same particles. Water. For example, for example, Hg, mercury and co. Mercury has the same molecules, has more force of attraction between cohesion. So in mercury, cohesion is more than addition. Adhesive forces refers to the force of attraction between two different, that is water and paper. Adhesive forces. And molecular moment transfer. If temperature increases, viscosity of fluids, how it changes? Okay. If temperature increases, fluids are liquids and gases. Okay. In liquids, cohesive forces are predominant. That is more. Cohesive forces more than molecular moment transfer. Whereas in gases, molecular moment transfer is more than cohesive forces. So, viscosity in liquids decreases when the temperature increases. Temperature increases, viscosity of liquids decreases. That means you write 1 by mu L, it will decrease. This is the inverse relation. That is liquids and temperature for the viscosity. Let's take for gases. For gases, both are increases. If temperature increases, viscosity increases. Temperature decreases, viscosity of gases decreases. In liquids, it is vice versa. Temperature increases, viscosity decreases. Temperature decreases, viscosity increases. This understand, I hope. The next topic is types of fluids. Ideal fluid. When a fluid is called ideal, it is incompressible and having no viscous. No viscous means frictionless. Frictionless. Okay, frictionless. No viscous. It is not exist in real life. Okay, these are imaginary fluids. Ideal fluids are real fluids. It possesses viscosity. They have viscosity. All fluids in practice are called as real fluids only. Newtonian fluids. The Newton's law of viscosity obeys a fluid obeys Newton's law of viscosity is called as Newtonian fluid. Does not obey the Newton's law of viscosity is called as non-Newtonian fluid. In other words, the same thing here also discussed. What means tau is proportional to rate of shear strain is called as Newtonian fluid. If it is not proportional, is called as non-Newtonian fluid. Non-Newtonian fluid. If the shear stress is more than yield value, that is yield stress, yield value, shear stress is more than yield value, then it is called as ideal plastic fluid. Okay, sorry, ideal. Types of fluids. which is ideal fluid. That means no shear stress. Tau is 0. Newtonian fluid, tau is directly proportional to du by dy. Non-Newtonian fluids, tau does not proportional to du by dy. The curve above Newtonian fluid and the curve below Newtonian fluid also called as non-Newtonian fluid only. The curve above Newtonian fluid is called as pseudoplastic. The curve below Newtonian fluid is called as dilatancy. Okay. If tau value is greater than yield value, then it's called as ideal plastic fluid. Types of fluid is over. The next topic is compressibility and bulk density. Bulk density is defined as the ratio of compressive stress to volumetric strain. Volumetric strain is change in volume by original volume. Compressive, that is, it is a block. This is force applied. The stress due to that compressive load is called as compressive stress. It is the ratio of compressive stress to the volumetric strain. It is denoted by letter K. I given an example for this. For the formula, take initially it is closed. The position of this is here 1. The place of 1 is changed to place 2. Then the volume will decreases. So the volume will decreases. Pressure in this case is increases. Pressure in this case is increases. Pressure in this case is increases. A volume will decreases. So the negative sign refers to the pressure increases with volume decrease, or volume decreases with increase of pressure. The unit of bulk modulus is Newton per meter square. In dimensions, Newton ml t power minus 2 divided by L square. That is dimensions are m, L power minus 1, t power minus 2 is the dimensions for bulk density. Compressibility, it is compressibility beta, for example, compressibility beta unte it is a reciprocal of bulk density. The units are also reversing. So the SI unit will be meter square per Newton. The dimensions are m power minus 1, L t power minus 2. The next topic is surface tension. It is defined as the tensile force acting on the surface of liquid in contact with gas. If it is a liquid surface, it contact with air, or the liquid surface is contact with another liquid surface. In both cases 1 and 2, a thin membrane is forming. This is due to surface tension. Best example for surface tension is mosquitoes on water surface. This is mosquito. let's say this is mosquito, this is water surface. It cannot immerse in water, it is stand on water surface. This is due to surface tension. It is denoted by the letter sigma. The unit will be kgf per meter. This is mkis unit. In SI unit, Newton per meter. The dimensions for Newton ml, t power minus 2 divided by L. L get cancelled. M L power 0, t power minus 2 is the dimensions for surface tension. And surface tension on liquid droplet. Liquid droplet. P refers to pressure intensity inside the droplet. Sigma is surface tension. D is the diameter of the droplet. P is equals to 4 sigma by D. How it get? Pressure force equating pressure force with force due to surface tension. Okay. Please remember these formulas for your problematic, for numericals to solve. Surface tension on a hollow bubble like soap bubble. Both in outside also it is contact with the air, and the inside also it is contact with the air. What the surface tension definition says: water or air, contact between water and air are two immiscible liquids. Contact, there is a thin layer forming due to tension. Okay, so it is two times of surface tension due to droplet. Okay, surface tension on a liquid jet is P is equal to 2 delta by D. It is like bar. This is L, this is D. The next topic is capillarity. Capillarity is defined as the phenomenon of rise or fall of a liquid surface in a small tube relative to the adjacent general level of liquid when the tube is held vertically in the liquid. This is, for example, in this liquid is present, capillary tube I insert in vertical. If the water rises in the capillary tube, it is called as capillary rise. If the water is held in vertical in the tank, the fluid in the capillary tube is falling, it is called as capillary depression or capillary fall. It is expressed in terms of centimeter or millimeter of liquid. Dimensions are L only, so M naught L t power 0. Expression for capillary rise or fall. The same formula, H is equals to 4 sigma cos theta by rho GD. Rho gamma is equals to rho G. So in place rho G you put gamma, 4 sigma cos theta by gamma D. In capillary rise condition, theta will be approximately 0, so the cos theta will be 1. So the capillary raise formula tends is equals to H is equals to 4 sigma rho GD, that is 4 sigma by gamma D. The value for theta for mercury and class is 120 degrees, approximately 130 degrees. Approximately 130 degrees. Summary. Fluid in the capillary tube is water. Water tends to capillary rise. The theta value will be approximately 0. Water more addition. Okay, where in case of mercury, Hg, mercury in capillary tube, more cohesion, the theta will be 130 degrees or 18 theta will be approximately 130 degrees. Capillary depression or capillary fall. Capillary fall. The next topic is vapor pressure. Consider a liquid which confined in a closed vessel. Take this is a vessel. Let's say this is vessel closed. It is closed. Water is present in this closed vessel. This closed vessel. This closed vessel. The temperature initially the temperature is 20 degrees Celsius and the pressure is atmospheric pressure. It is heating up. The liquid will vaporize at 100 degrees Celsius. At 100 degrees Celsius. Vaporization takes place. Molecules escape from the free surface of the liquid. It is closed. These are vaporized and accumulated at the free surface. These vapor molecules get accumulated in the space between the free liquid surface. This is a free liquid surface and the top of the vessel. This is the top of the vessel. These accumulated vapors exert a pressure on the liquid surface. These vapors exert a pressure on this liquid. This pressure is called as vapor pressure of that liquid. That pressure is called a pressure at which liquid is converted into vapors. Is called as vapor pressure. I hope this understand clear. It's clear. The next topic is cavitation. Consider a flowing liquid in a system. If the pressure at any point in this flowing liquid becomes equal to or less than, you consider less than or equals to, may be equal, might be equal, but it is less than vapor pressure. Okay, the vaporization of the liquid starts. Vaporization of liquid starts. For example, I take a river. I take a river. Here the pressure is less than or equals to pressure vapor pressure. Okay, vapor pressure. The bubbles of these vapors are carried by the flowing liquid into the region of high pressure where they collapse, giving rise to high impact pressure. The pressure developed by the collapsing bubbles is so high that the material from the adjoining boundaries gets eroded and cavities are formed on them. This phenomenon is known as cavitation. ఈ విధంగా ఉన్నప్పుడు బబుల్స్ అనేటివి ఫామ్ అవుతాయి, వేపర్ బబుల్స్. అవి హై ప్రెషర్ రీజన్స్కి వెళ్ళినప్పుడు కొలాప్స్ అయిపోతాయి. ఆ కొలాప్స్ అవ్వడం వల్ల ఏం అవుతుందంటే అక్కడుండే ఫర్ ఎగ్జాంపుల్ సాయిల్ అనుకుంటే ఆ సాయిల్ అనేది ఎరోడ్ అయిపోతుంది. అక్కడ పిట్స్ లాగా తయారవుతుంది అనమాట. ఆ పిట్స్ తయారవుతున్నాయి కదా, అవి వాటిని క్యావిటీస్ అంటారు. ద ప్రాసెస్ని ఏమంటారు అంటే క్యావిటేషన్ అంటారు. I hope this is understand. In the next class we discuss problems. Thank you.